So here's a linear first order differential equation. It's linear first order constant coefficients, and the p part, if I'm thinking about it as a y prime plus py equals q, the q part, I guess, is this Dirac delta function. So the Dirac delta function is that infinite spike, and that infinite spike happens at 2 seconds. So this function, the Dirac delta function shifted over at 2, is 0 until 2 seconds, then it's an infinite spike at 2 seconds exactly, and then it's 0 afterwards. So we're going to solve this with Laplace transforms. So our transform of y prime is sf minus y naught minus 3 times our transform of y is f. Now from the chart, our Laplace transform of the Dirac delta function is e to the minus s times where the spike happens at 2 seconds. So now I'm in the Laplace world. Let's absorb the initial condition. Y naught is equal to 1. And now we just need to take this equation and solve for f. This minus 1 is going to go over to the other side, so it's a plus 1. And then everything left on the left-hand side has an f on it, so we can factor out that f times s minus 3 equals, and now I'm going to write it as 1 plus this e to the, and then I'm going to divide out the s minus 3 bracket. So f equals, I've got a 1 over s minus 3 plus, now I'm not just going to divide this e to the minus 2s. I don't want to just divide that by s plus 1. What I want to do to match the pattern is square bracket 1 over s plus 1. And I want that because this is when I unlaplace, that e to the minus 2s is going to turn into the Heaviside step function, and then whatever, well, this is going to unlaplace to be e to the 3t. I need to express that in the same argument that the Heaviside step function is expressed at. All right, let's unlaplace. Inverse Laplace of f is y. Inverse Laplace of 1 over s minus 3 is e to the 3t from the chart. Plus, okay, e to the minus 2s, that's the Heaviside step function when we inverse Laplace. So at 2 seconds, so t minus 2. And then square bracket, 1 over s minus 3, we already know, would on its own unlaplace to be e to the 3t, but I want the argument inside the square bracketed piece to match the argument of the Heaviside step function. So everywhere there was a t, I put a t minus 2. And now I'm back in the Laplace world. Let's check the initial condition. At 0, the step function's not turned on yet, so this whole piece is 0. E to the 0 is 1. Yeah, so y naught equals 1. At least we've matched the initial condition.